variables and expressions. This is the first section that we actually start talking about some more algebraic type topics. Everything up until this point has been review, and actually some of this will be a little bit of review for you too, but this is the first kind of lesson where we actually start introducing some unknowns like variables, and then talking about expressions with those variables, and things like that. So before we jump in here, a couple definitions that you want. For instance, what is a variable? It's a letter or a symbol used to represent a value that can change. Most of the time we'll use X and Y, but you can use any letter that you want, A, B, C, all the way up to Z. Sometimes Greek letters are used for variables. Different pictures maybe, a smiley face, a Batman symbol, whatever. It just represents something that can change, okay? All right. And then we have things called constants. Big surprise here, constants are values that do not change, okay? So basically a constant can be any real number. Okay, meaning if you have something like x plus 5, x would be a variable. So this would be a variable. And 5 would be a constant. Okay, and we'll get more in depth with that once we look at some different expressions. This is just an introductory lesson. But variables can change: x plus 5, y minus negative 2.87, whatever. You can have any real number that's a constant, and you can have any variable that represents a value that can change. All right, so then the difference between a numerical expression and an algebraic expression. Numerical expression contains constants and or operations. So that's just like if you're going to be adding a bunch of constants or a bunch of numbers together, or subtraction, multiplication, division, all sorts of different operations can be involved, like order of operations. But you won't see any variables in there, just numbers. Okay? And then an algebraic expression can add in variables, basically. So variables can be contained within the expression with the constants and other operations such as addition, subtraction, multiplication, division, square roots, squaring, all those things, stuff that we'll talk about. Okay, so a couple examples here. Sometimes it's necessary to look at an algebraic expression and translate it into words, and vice versa. All right, so we've got our four kind of main operations of arithmetic: addition, subtraction, multiplication, division, and all the different things and all the different words that go along with that typically. So, for instance, plus could be sum or increased by, minus could be difference, less than, times, product, dividend, quotient for division. So those are things you can write down if you need little reminders. Okay, so this example here says give 2 ways to write each algebraic expression in words. Okay. You don't necessarily need to write all of that out, but just know the examples here that we're talking about. So what are 2 different ways that I could talk about A? So I could say x plus 3, or I could say x increased by 3. Okay, and then if we look over at B, m minus 7 would be the difference of m and 7, or 7 less than m. Or you could say 7 subtracted from m, something like that. All right, the next one's C, say 2 times y, or the product of 2 and y. Letter D, k divided by 5, or you could say the quotient of k and 5, or maybe k split up into 5 groups. Anything like that would be fine. And these are different ways that you can say these things. The one thing I want to point out about C, 2 times y, a bunch of different ways we can represent multiplication, especially when we talk about variables. So I could write all of these. So we literally have like six different ways that we can represent multiplication. Actually, there are some more. But you can have 2 times y in parentheses, 2 in parentheses times y, 2 in parentheses times y in parentheses, or just 2y. So a number next to a letter means you're going to multiply or double y. And then the last one is 2 times y using an x for multiplication. I don't usually use this one, and you can probably imagine why. It's because x looks like a variable. So we typically don't use that one, but it is kind of the way that you're used to seeing multiplication, like in elementary school. All right, and then we'll move on to the last topic here. Going from words into algebraic expressions. This is a little more challenging. And we want to look at these kind of key terms here. So for adding, put together or combine, subtract, how much more or how much less. Multiply, put together in equal groups. Divide, separate in equal groups. So let's take a look at each of these separately. I've got 3 of them. So Eve reads 25 pages per hour, and we want to write an expression for the number of pages she'll read in H hours. Okay, so she'll read 25 pages per hour, meaning that if she reads for an hour, she'll get 25 pages in. If she reads for 2 hours, she should get 50 pages in. If she reads for 3 hours, she should get 75 pages in, which is a relationship of 25 pages times the number of hours that she's reading. So if she reads for 4 hours, we put 4 in for H, and we get 25 times H, which will give us 100 pages, if she's consistent, which we assume with the information they give us. Okay? So that's equal groups of 25, basically, per hour. All right. All right, letter B here. Sam is 2 years younger than Sue, who is Y years old. Okay? So we're comparing Sam and Sue, and we want to write an expression for how old Sam is, or Sam's age. And anytime we're comparing to find out how much more, how much less, we're going to be talking about subtraction. Okay? So let's take a look at this here. Sam is 2 years younger than Sue, and Sue is Y years old. So if Sue is Y years old and you or Sam is 2 years younger than that, we'll say that Sam is 2 years younger, or Y minus 2. Now, they don't tell us how old either of them are, but we do know this much. No matter how old Sue is, if we put her age into this equation, Sam will be 2 years younger.